I'm Inaki Villar. The name is a little bit hard to pronounce. I'm Android developer since 7 years ago, almost. Since 2 years and a half, I'm working in Agoda in Thailand. And I'm Google developer expert in Kotlin and Android. And it's my first time here in Russia, and I'm very happy. I want to give thanks, first of all, to the organizers, volunteers, Ekaterine, Alexander, Alice, of course, because they helped me in the visa process with the tickets coming here. And yesterday we enjoyed a tour in the city center. And, well, we learned a little bit about the history of Moscow. That's a beautiful city. Okay, maybe you're wondering about this title, right? And it's a small reference of one album of 1999 of the Canadian DJ Richie Houghton. The album was called Dex FX and 909. It was a techno-electronic music album, and I think it was a little bit revolutionary at that time. And, well, at that time I had maybe 17 or 18 years old. Maybe that's I'm a little bit biased by this thing. And I'm not saying that R8 and D8 are revolutionary, right? So assist, but it's a huge improvement in building and tooling in the Android platform. Before we start, I want to say a funny thing. When I was doing the process to apply for this conference, call of paper, interview, receiving the feedback from the organizers, there was like the biggest event happening in Russia at that time in June. Do you remember? The World Cup, exactly. And I'm from Spain. Football is like a religion. I'm not going to say anything else. So you deserve the victory, right? And move on, right? Okay, so in Agoda, we are working very focused in the continuous delivery, and continuous delivery means that, well, for every pull request, we are executing more than 20,000 unit tests, 1,000 regression tests, and we are releasing every week, right? And we cannot afford a stop in the process of more than 4 hours. What's mean this thing? That's mean that if we have some problem in the building process, we have to fix as soon as possible. And that's mean that we need to understand every single step of the build process. Of course, if there are problems that is not related with Android, so it's not the case, but it's something related with Android, we have to be fast. There are a lot of teams depending on us, of the build process, of the deploying the application. So, and that's why I think that it's very important to understand a little bit how is this D8 and R8. Everything starts last year in 2017 when Google released this article saying that the new generation of D8 and R8 compilers. Until then, yeah, always we were using Proguard for shrinking, right, optimizing the code, and Dx for optimizing the Dex files. Of course, there is improvements in every Gradle version, but always we have been using the same tools. And the whole talk is going to, well, to understand what is the process and what's the benefits to use D8 and R8. Let's try to go through all the process. So imagine that you have a Kotlin file or Java file. So the first step in the build process is the Kotlin compiler or the Java compiler is going to generate a class file. Okay. Later, the Dex tool is going to transform this bytecode, this class file, into Dex file. Dex file is Dalvik executable file. And this Dex file is used by the APK. So we are going to deploy, or we are going to include these Dex files in the APK. This is, well, the highlight, actually, of the building process. Of course, we have more things because we have to package the resources, native things, whatever. But in terms of Java and Kotlin files compilation, this is the process. Let's focus on the in these parts. The bytecode, it's something that as Android developers with Java or Kotlin, we don't need to understand. But it's true that since Kotlin was released, we have more interest in the bytecode. At least in our case in Agoda, we try to understand better the bytecode because we need to see where is the bytecode generated by the Kotlin compiler to understand the coverage that we are serving in our testing, right? So why late in it it has a branch, right? Because usually if you see the bytecode for a late init instructions, it's generating an if null, and this is a branch, and Jacoco is going to complain that you are not covering this branch. But if I see this code, maybe that's something that say, oh my God, what is this? So let's try to put the things easier, and let's start with this simple function in Kotlin where we are returning the string hello. So the bytecode generated by the Kotlin compiler looked at this not null notation. That's something included by the compiler, but it's not the important thing. Let's focus in this thing. We are loading this string, this constant, and then we are returning the value. That's simple as is. And because the Java virtual machine is stick-based virtual machine, the bytecode is saying how many slots have consumed the program in that case. Something simple, 1. Of course, so this is a very simple example, and let's complicate a little bit the things. Now, instead of returning the string directly, we are going to assign the value to a read-only variable, and then we are going to return the value. Of course, the first thing is again the same. We are loading the constant hello world, and then we are storing this string in the stack with an index. Later, we are returning in the next line this string, or we are popping from the stack this variable, and then we are returning. So only with this thing, we have say to the compiler that we are doing something else. Okay, so we are ready to see something more complex in that case. Yeah, so this is the typical onCreate method from the life cycle of the activity generated, and this is the live code, or the bytecode generated by the compiler. So in the line 1, you can see this load constant with this number. This number is the ID generated by the build process with the R file that is mapping the IDs with the layout, right? So it's the same process, right? Instead of loading the hello world, we are doing another thing. Here we have something special, that is the invoke special and invoke virtual, right? What is this bytecode instructions? So invoke special is when you want to call constructors or private methods of the class. You are using invoke static for static methods and invoke virtual for public or protected methods. If we go behind, we can see that invoke special, we are calling the subver of the extended class AppsConf activity, and for invoke virtual, we are calling the protected set content view with the constant of the number. So it's quite simple, 3 lines, and nothing else to say. Invoke interface is nothing to say about that, but we have invoke dynamic. That's quite important. It was included in Java 7. And facilitates the bytecode or implementation for dynamic languages, right? Like Proguard, right? But you know that in Java 8 we are using these lambdas, and invoke dynamic is used to create a representation of the object of the lambda, but the lambda itself is called by invoke virtual. It's not called by invoke dynamic, but that's something that changed the game a lot in the Java world. So what about the Dex file? So we saw before that we need to transform the bytecode to the Dex file to deploy in our application the APK. Why? So think that Android has more than 10 years, and at that time, even now, so the constraints of resources are limited for the smartphones, right? In terms of power management, in terms of memory, CPU, even bandwidth. So it's different. So the engineers of Google think that change the JVM, or instead of executing the code in a JVM, we can use a different virtual machine. In that case, it was Dalvik, but as you know, it was deprecated, and now we are using ART. So what's the difference between both virtual machines? So JVM is state-based, so we have seen before with these instructions of store and load, so push and pop, the typical data structure. But Dalvik and ART are register-based virtual machines. Why? Because the engineers were thinking of Google, or Android in that case, that register base was giving better performance in the environment on a smartphone. And that's mean the numbers are like 30% fewer instructions and 35 more bytes in the stream of the invocation. So these numbers are from one presentation of Google I/O 2008, 10 years ago, where they were explaining more the internals of the Dalvik virtual machine. And that's something that, well, of course, in terms of performance as well. So that's the election from the engineers, use a register-based virtual machine. So, and how is the output? Well, the same example as we have seen before. And instead of doing these operations that we have seen before with having loading from the stack, storing loading, here we have a register that says where is the position of this variable, and we are returning the object. So that means that we are going to execute fewer instructions, because in the virtual machine, the stack virtual machine, we are doing all the time these linear and arithmetic operations with the stack. So the Dalvik specification is, well, I think it's a very good example of piece of art, right? Because at that time, imagine 10 years ago, the virtual machine of Java, it was very slow, right? Imagine, in top of that, put this virtual machine and actually build an awesome product like Android. Okay. So, and how is the structure of one bytecode internally? So if you're using Java P-C, you can decompile the class file, and you can see, well, the specifications say that we are using a different structure there. We have a header where we have some information, a constant pool. Remember that before we were loading this hello world or the ID for the layout is here where is the constant pool, and then we have different sections where we are specifying where is the class, the fields, the methods, and attributes. If you have two classes, if you have two files, the Java compiler is, or the Kotlin compiler is going to generate two classes, two bytecode. Okay. How is the Dexing? The Dex file format is slightly different, right? We have a lot of similarities, right? But the first thing that we can check is that we are not generating a different Dex file. So you have two classes. We are going to generate one Dex file, including the two classes, right? Why? Because we want to avoid the duplication of things. Again, we are running in a smartphone, and we want to reduce the overhead of having this multiple bytecode splitted. So everything is in class. Actually, the Dex file, it has two main parts. It has the header and then the body, right? In the header, we are going to, well, it's describing some metadata information, magic numbers, and the offset of the other parts of the Dex file. String IDs is not like the constant pools. String IDs doesn't represent only the primitive strings of the files, represents everything. A name of a method, or the name of a method is a string ID too. And you can imagine that internally, the Dex file is all the time referencing part per part. So if I have in my class two methods, the methods in the Dex file is going to contain a reference to the string ID that contains that. And it's quite efficient in that case. The types is the same. So I have a string type and I have a int type. So I mean, both are going to reference to the string IDs to point the thing. As you can see, is going to be a huge improvement. Proto IDs is for the returning types and the parameters for every method, and the same structure. So, well, now we have this Dex file. The thing is, we are going to include these Dex files in the APK. If we are doing a -SDK27, we can see that we are using 3 different Dex files, right? If we are using a -SDK14, for example, we are using 1 Dex file. And everybody knows here, if you are Android developer, the problems that we have with the multi-dexing, right? So, multi-dex nowadays, right? If you start to develop in Android 1 year ago, it's okay, everything, but before it was a nightmare, right? Everybody was like, oh, please, no, not this time, not this time. And no, well, that's true. That's true. and why? So there is like this number somewhere. No, it's not this number. Before, in the structure of the Dex file, I was saying that the string IDs or the header contains the offset of where the string IDs is going to start in the Dex file. So in the bytecode specification, the instructions to invoke a method in terms of method index reference is an integer of 16 bits. How is it? 16 bits? 65,000. So we can include 1 million methods in the Dex file, but we cannot reference because the specifications say that only you can specify with an integer of 16 bits. And that is the reason of the multi-dexing problem. Okay? Okay, so we have this APK Dexing file, and we have two virtual machines because, as you know, since Lollipop, we have the new Android runtime. It was included in KitKat on experimental way, but officially it was triggered in Lollipop. So in Art Android runtime, we don't have this problem of the Dexing because we are using another approach to compile the code, and this is a little bit, how to say, it's implementation details. As Android developers, we don't know or we don't need to know these things, right? But it's quite interesting how the Android engineers are working in those things. So mind that you have your Dex file, it's included in the APK, it's not finished here, the process. So internally, the Android, it's trying to optimize the Dex files to run in a better performance in your phone. In Dalvik, for example, once you are installing your APK, the Dex, and you are running your application, the tool Dex OPT was generating this optimized Dex file. And in Art, it was a new tool. And why is this different? So in Dalvik, we were using the just-in-time compilation. So that means that when we are installing the app, nothing happens, but when we were running the app, the optimizations were happening there. Why? Because in terms of space, it was better to execute the optimizations in just-in-time compilation only when we are running the application, not when we are installing the application. In Art, change the behavior, and we have ahead-of-time compilation. Once the application is installed, we are running the optimizations, and we are winning battery performance, for example, in that case. But it didn't finish here, so it not finished here. In Nougat, Android Nougat, we have, well, they included a hybrid model. And this hybrid model, it was with ahead-of-time and just-in-time compilation. That means that, well, it's a little bit changing between the versions, but when you install the app, now it's not having anything. When you are running the app, the just-in-time compiler is optimizing everything, but at the same time, is profiling this optimization. When the phone is idle, charging, the ahead-of-time compilation is running and providing more optimization of your application. And when you are running again the application runs fast. And it's not because it's because the ahead-of-time compilation and just-in-time compilation. And it's quite interesting how they are trying to improve all these things. In Android P, this is new, they try to implement a different compact Dex because in a multi-Dex environment, if you have this you have 3 Dex files, the string IDs, maybe you have some duplication values, and they have created a new compact Dex to share the resources between the different Dex files included in your IPK. So this is again quite interesting, implementation details. We don't need anything of this. And well, sorry, I forgot one thing in Android P, but before, so you can see very clear in this graph how works this hybrid model of just-in-time compilation and ahead of time to optimize the Dexing files in Marshmallow without this optimization and with Nougat. So in Marshmallow is linear, right? But in Nougat, once it's installed, we are profiling the optimizations once and once and once. Perfect. So in Android P, these optimizations not only happen in your phone, they are deployed to Google Play. So if this cloud profiling guided, so happen in your phone, is deployed to Google Play, maybe if I have the same phone as you, I'm going to enjoy these optimizations because the APK is going to include these ODEX optimized Dex files in the APK. So that's awesome. This optimization, again, is in the Android P, and we didn't hear a lot, but in the Google I/O they were talking about in this presentation, Android runtime. Okay, let's continue. Before the Android Gradle plugin 3, so this was the scenario when we have two classes, we want to do something, we change one file, the Java compiler, incremental compilation is going to generate the class. But in terms of dexing, so we had the problem that we had to compile everything again, and it was a waste of time. With the new, since Android plugin 3, they included the incremental dexing. That means that once you are only updating the A Java, the Java compiler is going to generate the A class, and the dexing tool is going to split the dex files, and you are going to generate one dex file per class. But later, there is another process that is going to merge all the dexing files. So still, your APK needs only one dex file. So you are going to split the dexing by class to allow the incremental dexing. And well, it's a little bit off topic, but incremental compilation is okay, incremental dexing is okay. What happened with incremental processing, right? Everything that we repeat, like a thing that, well, annotation processor is broken because, well, I don't know, whatever. So since Gradle 4.7, you can set up your KAPT, your APT, to have incremental annotation in your annotation processor. So not all the libraries are ready for that, but I have seen pull requests in Butterknife, in Parceler, that they are adapting for trying to have this incremental annotation that was something that was pending in Gradle 4.7. So, and here is where D8 appears. Here is when, instead of having this Dex tool, this Dex merging, we have the D8 tool. And D8 is going to generate better quality of bytecode than DX, with fewer instructions and better register allocations that we have seen in the register-based machine, virtual machine. So D8 is going to replace everything here. Let's move to the sugaring. The sugaring, as we saw before with the lambdas, right? This creation of the representation of the object with invoke dynamic, whatever. But in Android, sadly, we were using Java 7, right? And before Kotlin, it was like we were using RetroLambda, the Jack and Jill compilers, and Android or Google include one new step in the build process called the sugaring. That even that you are targeting Java 8, the thing is like during this process is going to replace the sugaring with a compatible Java 6, Java 7 code that later the Dex tool is going to include in your APK. Of course, so if you are targeting APK 24, 27, you can use more Java 8 things, but I don't know a single person or company that is using target MinSDK 26. I'm sorry, right? So for us, it's quite important, right? This process. This process is included inside the D8 too, right? So everything has merged into D8. There, Dexing tool, Dex merging, and D8. And that's quite what is that is D8. And now would be the show me the numbers, right? So this is the presentation from Google I/O when they were saying that what are the improvement. It was 16%, right? But always I say the joke with Anton, right? I have been maybe 7 times in Google I/O. Every year I saw a different graph with a lot of improvements in terms of building. And oh, come on, so always is the same, right? So let me show you the numbers of Agoda, of what we have included. So the main Dex file, well, first of all, I have to explain what is the main Dex file. So the multi-Dex problem, it was not only this problem. In Agoda, the main Dex file problem, it was something very critical for us. So the multi-Dexing, the support library for multi-Dexing, I mean, to support multiple Dexing files for versions previous Lollipop, works in a tricky way. So you need to patch the class loader to include secondary Dex files in the class loader in your application. But That means that you need to include in the main.dex file, so in the first main.dex file, all the classes required for your application before the class loader is patched. How works this process? So it's quite tricky too. This process scans the Android manifest. It gets all the activities and all the services, whatever, and then traverse every activity going to all the types and everything, and including this reference in the class, in the class, in the class, in the file, in the file, in the file. And that means that if your main.dex file contains one amount of classes that contains 65,000 methods, you are going to have this problem, right? And this problem is not like the other that is 65,000. Here you can have this problem with 4,000 classes, with 5,000 classes, with 8,000 classes. Our colleague, Igor, he did a workaround for the plugin 2.3, and it was working very well. But when we moved to 3, it was cyclic, and it was happening, and it was the worst, because that means that for development, we need to activate in the back of Proguard on going to the min-SDK21. And with the D8, this problem for us is not happening anymore. So we have seen a 56% of less, well, the size of the main.dex file in the back. In release, it was 75%, because this problem for us, for Agoda, it was in the back. But we researched a lot on this topic, and we have found companies that they had this problem on release. And if you have this problem on release, you have Proguard already. So this is a huge problem. And we found some improvement of the time of the debug builds of the 10%. So it was quite interesting for us moving to the 8. So we moved to the 8 in the 3.0. We were moving to 3.0. We didn't go to 3.1, never, because we had a problem with the, actually it was with the D8, right? Generating the nested lambdas in one cool library that we have called Cacao. It was causing some problems, and we didn't go. But the D8 actually is on since, it's present since 3.0. So in 3.0 is disabled, 3.1, 3.2, 3.3, of course, is enabled. So you can play with them, and this is the migration process. The first phase that I think that we are going to finish soon is when D8 and DX are living together, 6 months. Later, D8 is going to live with DX, but it's going to be deprecated in 1 year. And then the last one is when DX is going to be removed. So if you didn't move yet to D8, you have to think about it, because sooner or later in your build, at least, you're going to see that is deprecated. So, okay. So let's move to R8, is the new shrinker, the new Proguard for Android, full compatible. And let's explain a little bit more about what is well, Proguard, as you know. So it's like the tool that we were using since the first moment in the Android development, and it has 3 different or 3 main stages. So shrinking, obfuscating, and optimizing. Shrinking is removing the unused code or unused classes, method, fields from the application. And well, the typical thing is like when you are doing, I don't know, including Keras Java, including other libraries, so you are including a lot of code, right? And because at that time you wanted to avoid the problem of DX, or simply you want to provide a small APK, so why you have to include everything? With the shrinking process, we are removing everything that is not used. Obfuscation is trying to change, well, after the shrinking, the code that is there, so we can change these names, so trying to short and meaningless the names of the methods, variables, whatever. So this is something that actually, I don't know if it's, well, I have here 50-50 opinions, different opinions, because some people that we don't think that, honestly, I don't think that obfuscation in the client, it's something big, because at the end, it's something that everybody can try to discover, and at the end, all in most of the apps, the logic is not in the mobile. So, and this is the process. I jump optimize. I will explain later. And this was the process. We have the Java file. Java compiler is going to generate the bytecode, and Proguard is going to optimize this bytecode. Later, we can use Dex or D8 now. So that doesn't mean that you have to use R8 with the D8. So that's now actually how we are working in Agoda. So we have the Proguard. Proguard is optimizing the class, and we are using the D8 to generate the classes.dex. Proguard at the latest versions was hooked in the build process with the transformation API. That's something that comes from Gradle. It's quite interesting that allows you to manipulate the bytecode. Yeah, that's why one of the reasons, because Proguard is slow, right? And R8 is doing everything that Proguard is doing. So it's full compatible with Proguard in terms of files configuration, right? If you have been working with Proguard, you know that you have some files to configure, so it's full compatible. And we replace everything in the build process with R8. But we are removing D8 too, because D8 is included in R8 too. Okay, R8 is everything here. So I didn't say anything about optimization in Proguard because in terms of these tools, these kind of tools, shrinking and obfuscating are quite a standard operation. So I think that they're not rocket science, but optimizing, that's something that is quite complicated and where everything is going there, right? So the people of Proguard, the company, published an article a couple of months ago trying to say what the difference between the Proguard and R8. So these optimizations are quite interesting because in Proguard at least, and you can say how many times or how many cycles you want to apply the optimizations in your code. Because for example, if you are trying to inline constant, this inlining constant can trigger another optimization, right? That's why if you put 5 cycles, Proguard is going to be very slow, right? But in terms of similarities, that's the similarities in terms of Proguard and R8. So inlining, removing unused code, methods, constants, whatever. The people of Proguard, they're saying that they are adding this optimization that they are not present in R8. So making the methods private, making the methods static. But on the other hand, in terms of R8, we can see that there are more optimizations in terms of Kotlin. That's normal. But I have to say something. This is an article from the company of Proguard. R8 is all the time, well, it's working, evolutionating all the time, right? It's experimental yet, so it's not something that everybody's using. And for me, the most important thing, the people of R8 are working here, and the people from the Android framework here, right? So there are better communication and focus on Android. Show me the numbers too with Proguard, with R8. So these are, again, the numbers of Google I/O presentation. So in terms of the deck size, we have a decrease of size. It's not quite spectacular. And in building time, there is a huge improvement, right? Because I don't like the numbers in Google I/O, so I can give you some other numbers. So this is a use case, a multimodal application with Gradle 4.9, plugin 3.3 Alpha 8, 15 modules, and 1,000 classes. And R8 is disabled here. The methodology, it was a warm-up of 10 builds, and then calculating the different percentiles, right? This is for R8 disable, and the other is for R8 enable. So I'm going to compare the numbers better. And as you can see here, right is Proguard, R8 is left. So we have some improvements, right? But the numbers are not so spectacular, right? So why? The thing here is this code was generated to try into this example. So maybe the optimizations found by R8, they're not so cool, or they are not so optimized that we can do, right? So I don't think that these numbers can be very specific, right? Because depending on how is your code, depending how R8 can find optimizations in your code, is going to be greater numbers. So in Agoda, we are not using yet R8, is experimental, but we have the task. And we have done some experiments, and this is a typical assemble debug plus assemble release. and we have branches, right? And the phase 2 here represent Android Studio Beta. It was more than 2 weeks ago, with D8, and D8 only, no R8, and phase 3, Android Studio Beta with R8 connected. So 25% decreasing the time of 2 tasks. And bonus, so this was like 3 weeks ago, so I don't know if it's a joke or no, but that's the thing. So R8 actually, so the people that actually are testing R8, they're freaking out with the possibilities of the optimizations that they are doing inside the code. And it's quite spectacular, right? Because we can see a reducing of the Dex files and reducing the timing in terms of the build process. So again, experimental Gradle properties, you can enable, disable if you want. And the important thing here is like, because this happened for us, this happened for us in Agoda, you are not coupled with the version of R8 and D8 in the Android plugin. If you need to use another version, you can include in your class path, when you are trying to build the dependencies of the project, a different version for R8. That means that, well, important thing, you have to put this dependency of the class path before the dependency of the Android Gradle plugin. So if there are improvements that they're fixing the problems that you have actually with your code, you can include a new version with R8. And actually, that's the thing that we are doing. Of course, this is open source, and that means that you can get the code from the repository of Google. Again, R8 includes D8. So, and the tools and steps are quite easy. Clone the project, you have to start up the project to generate the jars. And then remember, so D8 is like this tool that is going to get an input that is going to be a bytecode and is going to generate an output that is a Dex file. Proguard is not acting file by file. Proguard gets one jar or a series of classes and is going to generate the optimized bytecode before the step of the dexing. So we were playing a little bit only to see the examples about the size of one Dex file, how you can improve these things, but I think is quite interesting. And I think that that's everything that I have for today for you guys. Thank you very much. And this is my Twitter, and спасибо.
Вопросы?
Yeah. Thanks a lot for the presentation. I had one question about the AOT compiling that's done, though you say it during idle time or charging time. Do you know how much time is spent to do that? And for instance, when you update your application very often, like every day or more than once a day, for instance, for debug application, is there a way to just disable the AOT compiler for your application?
Well, actually, there's like a bottleneck there, right? The history, I don't know if you remember with Marshmallow, when you were receiving an update, you were seeing this dialog, updating applications, right? It was a problem, right? They tried to avoid this problem with this thing, with ahead of time only in idling, but I guess, and I understand your concern, that if you are installing your application, maybe it's a problem. But that's why Google is trying to push this profiling guide, or cloud profiling guide, because they are going to include in the Dex file in your application, or the APK, the optimizations that they have to do. And it's going to go killing. I think there is a problem, of course, of this thing.
Thank you very much.
Все, вопросов больше нет. Ну, я думаю, тогда без вариантов.
Okay, thank you. Спасибо.
And you get the certificate and the